So set up your little box. We'll do one first. That's the easy one. Easier one. Make sure you have descending exponents. I do, so I don't need any placeholders. That one was easy. So far so good, yes? Okay. So the next one, maybe not quite as easy, but it's still not too bad. Okay, so here's what I mean by the improper fraction. If you have a 2 on bottom, if you'll divide first, so 0.4 divided by 2 is 0.2, or cut it in half, and then multiply by -5. So 0.2 times -5 would be -1. You understand what I'm saying? So cut it in half, then multiply by the top number. Cut it in half, multiply by the top number. And then you can do it in your head, and you don't have to worry about your calculator. It'll be faster. Okay. So I get 0.8, cut in half, which is 0.4, multiply by -5, that's 2.
So that's supposed to be negative.
Wait, is this, wait, which one? This is negative, isn't it? That's my fault. You're right. Okay. So if you get 1.2, then your next step is to cut it in half. Well, that would be 0.6, then multiply 0.6 by 5. So you can do all that in your head. You don't have to. It's not hard. Okay, so once you finish, this is based on what happened in the previous examples, so the 3 examples that you see on this page. What observation can you make about the connection between the zeros of a polynomial function, their factors, and synthetic division? So, right here, they are zeros. Right here, they are factors. And then this is what happens on the synthetic division.
So the remainders, the factored equations, and the zeros are all the same?
It's all the same. So anytime you divide with a factor, which is a 0, your remainder should be zeros. That's why they're called zeros. It's one of the reasons why they're called zeros. Multiple reasons. I just love it when math makes sense. Okay, so it says complete the following statement. If A is a 0 of a function, then the factor blank is a factor. So how would you write it as a factor? If A is the 0, how do you write it as a factor?
Mixed velocity.
Yeah, that's it. So, and I know I've said this before, and I will probably say it, you'll probably hear me, especially those of you who are juniors and are going to have me for calculus, you'll probably hear me say it 100 more times. Anytime you see a lowercase a like that, they mean for you to recognize it as a number, a real number. That's just, they're just using a because it could be any real number. It could be 3, it could be 7, it could be 69, it could be -5. But a represents a real number, whereas x is a variable. So anytime you see an A, what they mean is, if you are given a number, and you're told it's a 0. So they say, hey, 7 is a 0. How would you write it as a factor? And you would just write it as x minus 7. That's all I want to know. Does that make sense? Okay, so x minus a is a factor of f of x. When f of x is divided by this factor of x minus a, then the remainder should be 0. Okay, so we're going to answer the following questions about factors and synthetic division. If 2x plus 1 is 2x plus 1 a factor of this polynomial, show and explain your work, and then what is the graphical representation of the result of this work. So how are we going to determine whether or not it is a factor? Because this particular polynomial isn't factorable. Not by, the only way you could factor this would be what method? Grouping, because it's got 4 pieces, and if you look at it, you can look at it real quick and see it's not going to work by grouping, because 11 is a prime, so it won't factor into something that has the same thing as the first piece. So it's not factorable as I know it. So how am I going to prove whether or not this is a factor? Synthetically divide. When you synthetically divide, if it's a factor, what will happen?
It'll have no remainder.
It'll have no remainder. So that's what we're going to do. We're going to set it up to synthetically divide. So remember, just in case you have forgotten, 2x plus 1 has to equal 0. So move the 1 over. So I get negative 1/2 is what's going in the box. 3, 2, 1, constant. So I don't need any placeholders. So I got a remainder of 0, so yes, 2x plus 1 is a factor. So it asks, what is the graphical interpretation? So what does that mean?
There's a point on the x-axis and maybe we'll have.
Exactly. So I'm just going to say the polynomial. What shape is this polynomial?
It's a cubic.
Right, it's cubic, so it looks like this. And we know for sure that the polynomial crosses the x-axis at x equals negative 1/2. I should probably say touches. We don't know for sure that it crosses. We could figure that out, but we don't know that yet. Okay, so you do number 2. Okay, what did you put in the little box?
Negative 2.
Did you get a remainder or no?
Yes.
Yes.
What was your remainder?
Negative
36.
Either way, it's negative 34, but is it a 0? So can we make any sort of graphical interpretation about this particular thing? The only thing you can definitely say is that the graph doesn't touch at negative 2. That's the only thing you know for sure, but anything else you don't really know. because we don't have enough information. All right, so for number 3, it says consider this function, and they gave me a new function f of x right here. They asked us to divide by x minus 3 and then factor the quotient. So the first thing you're going to do is synthetically divide, just like we've been doing. Careful on this one because you are missing the squared value, so you need a placeholder. Okay, so once I did the synthetic division, it tells me to factor the quotient. Remember, the quotient is the answer. This is not the answer yet, because it doesn't have all the x's on it, so I need to put my x's on it. Remember, our original function started cubed, so you go down 1. So this is going to be 1x squared, or just x squared, plus 3x minus 4. No remainder, so you don't have to put anything else. Now, factor that, because it factors.
X plus 4x minus 1.
X plus 4x minus 1. Okay, so now they're telling us, go back here to the original function, and we're going to divide by x minus 1. So I synthetically divided, I got to here, I had to go back and put my answers on it, and then I factored as x plus 4x minus 3. One more time, this time they're telling us to do it by x plus 4. Okay, so based on what we did, this is a factor, because I got a remainder of 0. Then I factored and I got these two. This one is a factor, because I got a remainder of 0, and then I got to this quadratic and I factored again. Then this is a factor also, because I got 0. So you've got all 3 factors right here. X minus 3, x minus 1, and x plus 4. But look, I also have them all right here. X minus 3, x minus 1, and x plus 4. And they're all right here. X minus 1, x plus 4, and x minus 3. So if you know one of them, then you can synthetically divide and then factor and find the others. Now, if we looked at this problem just like this, we could have can't factor it because it's x cubed. So it looks like it would factor as a regular, if it was x squared it would, but it's x cubed, so you can't factor it from the beginning. But if you can figure out what one of your zeros is, then you can synthetically divide and you can factor from there. So based on what we just did, our zeros are, now these are written as factors. They ask us to write them as zeros, which means x equals. So that the zeros are actually x equals 3, x equals 1, and x equals negative. Okay, so they've given me a function at the top of the page, and they've given me one of the factors. So they want you to synthetically divide and write the remaining in factored form. So go real quick. I'll give you a second.
What is completely factored form?
Like this.
Oh, okay.
So I synthetically divided. If you're right here on this step and they've made this statement, x minus 1 is a factor, and you synthetically divide and you do not get a remainder of 0, then you've made a mistake in your division. Check for a placeholder. This one didn't need one, but that's usually where your mistake is. Sometimes you just add wrong or something like that, but if they have told you it's a factor, this has to be a 0. So I got that, which as a trinomial looks like this. Then I had to use bottoms up method to factor, so then I factored. This is written in completely factored form. It does not have to be in that order, any order of the 3. Is everybody okay? Any questions on that one? Everybody good? Okay, let's try the next one. This time, notice what they asked. They didn't ask me to write it in completely factored form. This time they asked me for all the zeros. Okay, it asks me what are all of the zeros. So looking at this, how many zeros should I have? 3, because it's cubed. So I used -2 in the box, and I synthetically divided, and I ended up with 2, -1, and -6. So I made my trinomial, then I had to use bottoms up method again, and so I ended up with these 2 additional factors next to the one they already gave me. Then you have to write them as zeros. So the one they gave me was x equals -2. I found x equals 2 and x equals -3/2. All right? Questions? Okay. Alright, so number 7 is a little bit different. It says for what value of k is the factor x minus 2 a factor of this function? Now this is going to take us back to what we did yesterday. If x minus 2 is a factor, what should the remainder be?
0.
0. So remember what we did yesterday. If I take that value and plug it in, it should also equal 0. That's the remainder theorem. It says if you plug this number in to the number where x is into your polynomial, it should equal the remainder. So the remainder of this one, if we want it to be a factor, should be 0. So p of 2 needs to equal 0. So I'm going to take this function, and I'm going to plug 2 in for every x. And then set it equal to 0. Okay. I got K equals 11. Do I have a K?
Yes.
Okay. I don't have a key for this page. I don't know where it went, so. I figured since it came out nice, that was probably right. Okay, do number 8. Exact same thing. They're saying we want this to be a factor, which means remainder would have to be 0. So this time, just don't forget, this is going to be q of negative 3. Because remember, our actual thing is x minus a, so this would be a negative 3. Needs to equal 0. Okay, where'd my 6 go? Dang it.
Wouldn't that be a positive?
I lost my 6.
So wouldn't that be a positive 81 though?
Yeah, because.
Oh, yeah, because this is negative, you're right. Okay, so 81. And somehow I just ignored my 6, like it wasn't there. Yeah. Oh, it's not bad. Well, it still doesn't, it's still a fraction, isn't it? Or no? 144. Oh, it's not. 16. Negative 16. Sorry, negative 16? Okay,
First question. I got negative.
because I had to move my 9K to the other side, so it became negative.
Oh,
Okay, so number 9, they're asking me if x plus 1 is a factor, and if it is, how many times? So they're asking me essentially, is it possibly a double root, or maybe even what we would call a root with a multiplicity of 3? So we're going to have to synthetically divide. 4, 3, 2, okay. I have all my descending exponents. I'm going to put a negative 1 in the box. Okay, so it is a 0. Now the question is how many times? So I'm going to synthetically divide again using these numbers as my new coefficients. So, and if it works again, that means it's a root at least twice. So I'm going to put a new box, and I'm going to put the same value, negative 1, and I'm going to try it all over again. And it is, again, so we know it works at least twice because I have a 0 here and a 0 here. So I'm going to try it again and see if it happens to have a multiplicity of 3. Just in the interest of space, I'm going to take these and rewrite them up here. So negative 3, negative 1, 2. You don't need the 0 in there. One more time, we'll see if it works again. It does, it works again. So 3 times it's a factor. We'll try it one more time. This time it's not. So 3 times I got zeros, which means x plus 1 is a factor of 3 times. And you could find the other one right here if you wanted to, because this should have 4, and you found 3 of them, x plus 1, x plus 1, x plus 1, and then the last one's right there. It's that's the linear value, so you can find it. They didn't ask you to. Everybody good? This is so easy. We like it because we're so good at factoring. We